Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of August 4th this time around. Tough week. About every month we have a week that's really tough with moonlight, once every 4 weeks, roughly speaking. And it depends how it's phased with where our week starts. And it's just about, we're in a pattern where it's just about as bad as it can be right now. We'll slip out of that pattern soon. But we start over 80% full when the week starts on the night of August 4th, the morning of August 5th. It goes to full, and then it's waned away only to about 95% full by the end of the week. So the entire week, the moon is more than 80% full, and this is just about as bad as moonlight gets for observing things. We can still see bright objects, and that's what we're going to talk about mostly. On the 5th, the morning, a.m. of the 5th, Tuesday morning, Venus and Jupiter are separated by about 6.5 degrees. As always, remember, that's about 2/3 of a fist width at arm's length that separates Venus and Jupiter in the morning sky. Both should be fairly visible right now. Venus is heading for a conjunction with the sun, and it's filling out. It's almost 80% full right now as it gets around on the far side of the sun. So enjoy that telescope view of Venus if you get the chance. It's going to be soon. It's going to be so close to full, it's going to be hard to tell that it's phased. And by the end of the week, it's moving rapidly, so that by the end of the week, in the morning of the 11th, the two make a nice bright pair in the morning sky, and they're less than 1.5 degrees separates them. So you're going to see this separation between the two planets decreased by about a factor of 5 this week. So that's a dramatic change and something fun to watch. We are, of course, approaching the Perseid meteor shower. As we always talk about with the meteor showers, they're like big tubes of stuff that we fly through. And so they last for a long time. Perseid is a long one. You can see increased meteor activity for quite a while around the peak that's going to occur. Not the week we're talking about here, but the next week at the early part of the week. But the moon interference is pretty bad. So just keep that in mind. We want to get past peak a little bit next week. We'll talk about that. But you might be able to see a few stray meteors this week. Just too much moon to really see anything. So let's talk about Cepheus is what we're going to talk about as our primary object this week, and the stars there mostly. And so Polaris is the end star in the handle of the Little Dipper. Polaris is right on our rotational axis, or very, very close to our rotational axis, so it doesn't appear to move in the sky, and that's what makes it the North Star. So it's our North Pole star. We picked this week because, the moon is south of there a little way, so we're as far away from this interfering moon as we can get. Now, early in the week, the moon will set before sunrise just a little bit, and late in the week it's going to rise after dusk just a little bit. So you might have, at the beginning of the week, you might have a little bit of a window to observe some objects in the morning without too much moon interference, and at the end of the week, in the evening, you might have a little bit of that window, but you're not going to have very much. Anyway, Polaris is our North Star. It's about almost 12 degrees. 11 5/6 is what I wrote on the board. So it's almost 12 degrees from Polaris over to the Gamma star Errai in Cepheus. So we're talking about Cepheus this time around. And that's a nice bright 3.2 magnitude star. We've got a lot of 3rd and 4th magnitude stars. Decent sky, should be able to see these stars. Much light pollution or much like the smoke we have now while I'm recording this is intense, and so we don't really see much of anything right at the moment. It will wash this stuff out. So Errai, something to think about here is that our rotational axis, it points, we're spinning and it points this direction toward Polaris, but we're precessing around, our rotational axis is precessing around, so the pole actually changes where it's pointing in the sky. And in about 2,000 years, probably a little less than 2,000 years, the rotational axis is going to be pointing at Gamma Cepheus, or Errai. So Errai will be our North Pole star in a couple of thousand years. So mark it on your calendars. Get out there and watch us as the pole is shifting over this direction. The rotational axis is shifting over this direction to point at Errai. We'll see it. We'll see the moving that direction, and that will be the star, the bright star that's closest to the North Celestial Pole like that. We move about 12 degrees up this direction. This was a little bit less, 12, 11 degrees up this direction, and we come to Iota and Beta. Now, Beta to Iota If you hop that same distance over here, you come to M52 is an open star cluster. It's a fine open star cluster. It's not one of the most dramatically beautiful open star clusters, but it's not a really sparse or hard to find one like we tried to do last week. So it's a nice open star cluster across there. Just go beta to iota at about the same distance on across. Again, early in the week, do this late at night. Maybe the moon will have cleared enough. Late in the week, do this very first thing after dark. Maybe the moon will not have risen enough to wash that. That's your deep sky object is M52, one open star cluster this week to go out and try to find with all the moonlight around. Beta's a 3.2 magnitude star. I didn't write iota down. It's going to be 4th magnitude star. And we're going to move up to beta before we do that. Beta is a great star to look at with your small telescope. It's got 14 arc seconds. Remember, an arc second is a 60th of an arc minute, and an arc minute is a 60th of a degree, and a degree is about your finger width at arm's length. 14 arc seconds is a big separation. It's got an 8th magnitude companion. It should show up in just about any telescope you have. Should be able to see this companion star to Beta. Beta is a famous variable star. We're just not going to talk about much this week. We can come back and talk about it at another time. So drop down here to Aldebaran, the alpha star in Cepheus. Again, I didn't write the magnitude on there. It's going to be about 2.5 magnitude over here. Move across over this direction to Zeta, and Zeta is a 3.4 magnitude star. To me, this I've stretched this a little bit much. I think this is collapsed down this direction, maybe more across there, something that looks like that. It looks like a house, and in this case, pointed towards where it's pointed towards the pole, it looks like an upside down house. So this is the roof, the peak of the roof line of the house, or maybe a garden gnome. Maybe that's the hat of the garden gnome, and that's the body of the garden gnome. I don't know, but that's what Cepheus always looks like to me when I see it in the sky. And so, in the middle of all of that, there's a 4.3 magnitude star right about there in the middle of the house, part of the house. And this star, it's 4.3 is not real bright, but it's got no other really bright stars around it, so it kind of stands out there in the middle just a little bit. Xi is that star. That's a fine binary star too. Something for us to go out and look. 6 arc seconds, about half as much separation, but the two components are brighter. The one component, the companion star, is brighter. About 4.5 and 6.5 magnitude, something like that are those two stars. So it's a great binary star. In the time we've been observing it, it's opened up its separation a little bit. It was a little bit closer, so we can see the orbital motion of these stars. And so I think about 6 arc seconds is where we are right now. So let's look at 2 other stars, 4.2 magnitude epsilon and 4.1 or so magnitude delta. And it's just or so because delta Cephei is really probably the most famous variable star of all. It's the prototype star of the classical Cepheid variable stars. And so we call them Cepheids because of delta Cephei right here. It varies from 3.6 magnitude to 4.3 magnitude on about a 5.4 day period. I think even with the full moon this week bothering us, you might be able to detect that change in brightness. That's a fairly significant, noticeable change in brightness. Compare it to these 2 stars around, or better yet, take a picture every night. And if you take a picture every night in 5.5 days, it's going to go from wherever it is, brightest, let's say, to dimmest, back to brightest, or wherever it is in its phase like that. And so you'll cover the whole cycle in 5.5 days. So a week or 2 of observing, you should be able to see the star getting dimmer and brighter. If you take a picture of it every night, 2 times a night over the course of a week, that would be a great thing to do, a great project. And it's really for that, for that project, what makes it so special is just how important to this star is, how important the Cepheids are. Because what Henrietta Leavitt figured out over a century ago now is that these stars, the time it takes these stars, that period, that 5.4 days, is directly, it's really tied to how bright the star is overall, how much energy it's emitting into space, what we call its absolute magnitude, what its luminosity, its total energy it's emitting into space is. And if you know how bright something actually is and how bright it appears, you can tell how far away it is, unless, of course, there's a lot of dust or gas scattering light out between you and that object. And then that gets to be a problem that we need to talk about some other time. But in theory, these are what we call standard candles because their period of oscillation, the period of variability, determines is directly related to how bright they are intrinsically. And if you know how bright it is intrinsically, how bright it appears, you know how far away it is. And these are among the most important distance measuring tools because they're big bright stars and you can see them all the way across the galaxy. You can see them in distant galaxies, other galaxies outside, not the most distant galaxies, but galaxies outside the Milky Way, so relatively nearby ones. You can see these Cepheid variable stars. And so this is really important in the cosmic distance ladder as we measure distances out into the universe. This is an incredibly important object. You have a chance to go out and take pictures of it and measure that brightness changing. And I think that's fun. I think you should give that a try. So that's what we got here. Across there, if you go from beta to zeta, about that same distance across, you come to a little diamond shape of stars that marks part of Lacerta. And we'll come back to that. But for now, just go ahead and make that hop while you're out here doing it. See if you see that diamond of stars out there. And if you haven't seen Lacerta, the constellation before, now you have. And so it's a chance to go out and look at that. And I really think that's all we've got in this terribly moon-obscured week. Go look at the most famous prototype of the Cepheid variable stars. See if you can find open cluster M52. It's got to be a challenge with the moonlight that we have out there. See what you can do with the stars of Cepheus and a couple of nice variable stars in there. You got Jupiter and Venus closing on one another. If you've been watching Saturn, Saturn's still there, and Saturn's going to be great to observe. Keep watching Saturn. Those rings are edge on right now, knife edge. They're going to be opening up over the next few years. You're going to be able to see the rings open back up and see space between the rings and the planets better. But you still got that in the evening sky. By next week, we'll be able to go and try to find a couple more deep sky objects. As always, thanks for watching, everybody, and we hope you have a great week ahead.